Hey, it's Ikeen Alston here. I've got an abacus in front of me. I have several abaci in front of me. To say abacuses would be profane. It's Latin, so the plural of abacus is abaci. Hey, but in any case, not that that's important for the use of the device. It's funny to me. Hey, these are some abacus that we've made in my program over the years. They are craft abacus, I call them. Just some beads, some hot glue, some craft sticks, some chenille rods, and you're off to the races. This tool is really useful to understand arithmetic, how to add, subtract, multiply, and divide. And actually, a really cool thing is that when you put a bead up, you're adding. Or if you put a bead up in a certain way, you're multiplying. So it shows the repeated addition is multiplication. If you're putting a bead down, that's subtraction. But if you continually subtract according to a pattern, then that's repeated subtraction, which is division. So this tool can add, subtract, multiply, and divide. It's over 1,500 years old. It's called a Chinese swan pan, S-U-A-N space P-A-N, swan pan abacus. This one here is a little bit different. We're not going to talk about this one just now. This is a Japanese soroban. Right? It has one bead up and four below, as opposed to this one here, that's the Chinese, that has two beads up and five below. Two up, five below. One up and four below. And they both work the same way actually too. Right? So this one that I'm going to show you just now has the two up and the five below. So this is like a little kitty craft out because this is the real big thing. I'm going to move it aside for now. So here we go. We got 1, 2, 3, 4, 5. I can trade for 5. I got 10, 20, 30, 40, 50. Trade for 50 if I wanted to. We'll get to that later. I got 100, 200, 300, 400, 500. And then I got 1,000, 2,000, 3,000, 4,000, 5,000. And if you take a look at the top here, this upper deck here, that's a 5. So if I want to trade for 5, these go away, and I just go like this. 5, 6, counting on. 5, 6, 5, 6, 7, 7, 8, 9, 10. Sounds like a 10, so we'll go to the tens place and trade for 10, 10, 11, 12. And you can see that 1 in this place is a 10, and a 2 in this place is just 2. So that's 12. Air write it. 1 and 2, and you see 12, right? Okay. 5, 10, trade for 1, 10. 50 and 50 trades for 100. 100, air write it. 100 is 100. 500 plus 500 trades for 1,000. 1000 is 1,000. Air write it. 1000. Right? And 5,000 plus 5,000, we can't trade for 10,000 because we're out of space right here. Let me show you what the device looks like when you actually label it. Okay. So now you have the same device here, but you have your powers of 10. And we have 10 to the 0 power, which is the ones or the units place, and that's just a quantity of 1. So that's just 1, it's telling me that it's 1 because we have it written there. 2, 3, 4, 5. Swap out, trade for 5. 5, 6, 7, 8, 9, 10. That takes me over to 10, 20, 30, 40, 50. Trade for 50. 2 50s be 100, 100, 200, 300. We abbreviate it. 400, 500. That would trade for 500 plus another 500. That'd be 1,000, 1,000, 2,000, 3,000, 4,000, 5,000, and we can't do the trade there. 10 to the 0 power. It's really, really cool because you can see exponential notation can show up really, really early without a lot of explanation to understand what it means. 10 to the 0 power is just the unit ones or the ones place, and that's just a quantity of 1 right here. 10 to the first power is the tens place. So that's just going to be a 10 with 1 0. Oh, 10 squared, or 10 to the second power, is 10 to, well, sorry, the hundredths place, right? And we got 1, 2 zeros. Oh, I think the power is trying to tell me how many zeros I need in this case for base 10. 10 to the third power, or 10 times 10 times 10, 10 cubed, the thousands place. Oh, that's just a 1 with 1, 2, 3 zeros. So there's your place value on the abacus. It's really not that challenging. It's a really, really great tool to understand. If we flip it over, oh, whoa, 10 to the 0 power, we just did that. 10 to the first, we know that. But now we have this thing called negative exponents, right? Which are always going to be a fraction, right? So you got 1/10. 10 to the negative first power is 1/10, or 0.1, which is the decimal form of 1/10. So all aligns. And then this little spot right here is the word and, kind of messy. Little decimal point there, right? So I could show $3 and 1 cent. Or I could show $3.10, or 11, or 12, or 13, or 14, or 15, and trade that out for 5, right? So this is really useful because it's double-sided. This side we have whole numbers, and then on this side we have negative exponents, which are fractions, so we can work with coins and money and such things. Flip it over, now it's just whole numbers, okay? Thanks for watching.